Alright, Assalamualaikum warahmatullahi wabarakatuh dan hello everyone. Okay, so kita akan continue kita punya kuliah masuk kepada chapter 4 which is work, energy and power. Alright, so previously dekat chapter 3 kita dah belajar force, how we want to calculate total force in x axis, y axis dan juga kita dah belajar force ni ada beberapa jenis yang kita boleh kategorikan. Alright, so dan juga ada last chapter 3 kita ada belajar how we want to calculate the value of tension. Alright, so now dalam chapter 4 ni dia ada hubung kait juga bagi apa yang kita belajar di dalam chapter 3 which is berkaitan force. Okay, so work chapter 4 kita akan belajar work, energy and power. Alright, so kita akan tahu apa itu dimasukkan dengan work dan energy dan juga power. Alright, so di dalam chapter 4 ni kita akan belajar work done by constant force, kinetic energy and work energy theorem, gravitational potential energy, mechanical energy and its conservation, and last sekali kita akan tengok power. Alright. Okay, the first subtopic yang kita akan tengok adalah work done by the constant force. Okay, so kita tahu definition of work is done when force acting on a body and move the body. Okay, so the work done by the constant force is given by the scalar product of the vector F and S. Alright, so kita tahu F ni adalah F adalah vector quantity. Okay, darab dengan S, which is S ni adalah displacement. Alright, so W adalah simbol bagi work. Okay, so kita boleh tulis work is defined by force times dengan displacement ataupun Fs cos theta, which is theta ni adalah the angle between force dan juga displacement. Okay, so for example, kita ada force upward. Alright, so and then kita punya displacement adalah ke kanan. Okay, so the angle between the force and displacement ini adalah theta. Okay, kita panggil theta, which is theta is the angle between force dan juga displacement. So you need to know where is the direction of force and the direction of displacement. Alright, now the unit bagi work is joule. Okay, so or we can put it 1 joule is equal to 1 Newton meter. Selain daripada joule, kita juga boleh tulis unit bagi work adalah Newton meter. Kenapa Newton meter? Daripada equation bagi work, we know that force darab dengan S, betul? Okay, so unit bagi force adalah Newton. Okay, and then unit bagi displacement adalah meter. So kita dapat Newton meter. Okay, clear? Okay, so the work done by a constant force is defined as the distance moved multiplied by the component of the force in the direction of displacement. Alright, so kalau kita dapat lihat gambar rajah ni, seorang perempuan menarik sebuah kotak daripada satu kawasan kepada satu kawasan. Okay, so daripada kawasan A kepada kawasan B. So ini pergerakan daripada sini ke sini kita panggil dia sebagai displacement ataupun jarak. Okay, so force yang dikenakan adalah macam ni. Okay, ada satu angle. Ini adalah force yang dikenakan ataupun yang ditarik oleh wanita tersebut. Okay, so the angle between force dan juga displacement kita letak dia sebagai theta. So ini adalah angle between force dan juga displacement. So kita boleh calculate the value of work is Fs cos theta. Okay, for example, theta kat sini sama dengan 20 degree. So dia akan jadi sama dengan Fs cos 20 degree. So we can know the value of work. Alright. Okay, so this is the example by how we want to calculate work in a horizontal movement. Okay, so now if you look at the figure A, okay, so the direction of force and displacement adalah in parallel. Okay, so there is no angle between force. No, it's not angle. The angle between force and displacement adalah 0. So the theta is 0 degree. So we know that cos 0 is equal to 1. So the equation becomes W is equal to Fs. Alright, now if you look at the figure B, the direction of force is to the left and the direction of displacement is to the right. Okay, so now the angle between force and displacement is 180 degree. Alright, so now cos 180 is equal to negative 1. Okay, so the equation for works, it will become work is equal to negative Fs. Alright, so which is negative comes from negative 1. Alright, if you look at the figure C, the angle between force and displacement is given by theta. Alright, so the work done on the object can be calculated by using the equation W is equal to Fs cos theta. Okay, if you look at the figure D, the direction of force is upward and the direction of displacement is to the right. So the angle between force and displacement is 90 degree. Okay, so if we calculate the cos theta, cos 90 degree is equal to 0. So that's why the work done by this force is equal to 0. Okay, clear. So from this we can know that if the work done, the direction of force and displacement is same, the work done is positive. If the direction of force and displacement are in opposite direction, it will become negative work. Okay, or if the angle between force and displacement is 90 degree, the work done will become 0. Okay, for example, example 5.1. Okay, a constant force of 24 Newton is applied action to a block with undergoes a displacement of 7.5 meter to the right along a frictionless surface while the force acts. What is the work done by the force? Okay, so they give the value of force is 24 Newton and the direction of displacement is to the right. So the angle that are given is 30 degree, but it's in this direction. Okay, so if this is direction of force, okay, so this is the direction of displacement, so we know the angle here is 30 degree. Alright, so we can calculate the angle here, right? So it will become 180 minus 150, it will minus 30, it will become 150 degree. Okay, so the work done by the force, we can calculate W is equal to Fs cos theta, which is F is 24, S is 7.5, and cos angle is 150 degree. So we can get the value is negative 155.9 joule, right? Okay, so look at example number 2. A concrete block is pulled 7 meter across a frictionless surface by means of rope. The tension in the rope is 40 Newton. So the tension here is 40 Newton. So and the net work done on the block is 247 joule. What angle does the rope make with the horizontal? Okay, so they give the value of work is 247 joule, force is 40 Newton, and displacement is 7 meter. Okay, so we need to know the value of angle. Okay, so from the equation, W is equal to Fs cos theta. So we know the value of work, value of F, S, and we can calculate the value of theta. So if you calculate, you will get the value of theta is 28.1. Alright, clear? Okay, so exercise 4.1. Okay, so if you look the exercise 4.1, the displacement given is 1.5 meter. So this is the value of displacement. And then horizontal force is equal to 5 Newton. Frictional force is 1.6 Newton. Okay, A, the work done by the 5 Newton force. So dia tanya how much the value of work done by the 5 Newton force only. So the work done by 5 Newton force is Fs cos theta. So force given is 5, S is 1.5. Okay, so the angle between force and S is parallel. So cos 0. Okay, so 5 times 1.5, it will become 7.5 joule. Alright. Question B, the work done by the frictional force. Okay, so they ask the work done by the frictional force. Okay. Fs cos theta. Okay, so this is the frictional force. Okay, so frictional force is given by 1.6 as 1.5, and then cos, the angle between frictional force and displacement is 180 degrees. So we calculate and we get the value is negative 2.5 for 2.4 Newton. Okay, the total work done on the book. Okay, so the total work done on the book, okay, just sum up between the work done by the force plus dengan work done by the frictional force. So 7.5 plus negative 2.4. So it will become 5.1 joule. Alright. Okay, next is the work done by the gravity force. Okay, so tadi kita dah tengok work done by the force. Okay, so ini adalah work done yang melibatkan dengan gravitational force. Okay, so kalau nampak gambar ni, seseorang itu mengangkat sesuatu objek. Okay, as long as the man is not moving upward or downward this object, so he does not do any work. Alright, so because the force that yang bertindak terhadap dia punya displacement tu tidak merubah apa-apa the value of work. Okay, so this is the question. Work done on an object is 0 when force is 0 or S is 0 and the angle is 90 degree. Okay, so the work done will become 0 if we have the value of force 0, S 0 or angle is 90 degree. Alright, so work done in vertical movement. Okay, so we consider a ball is thrown up or down, shown in figure. Okay, so for example in the first figure, okay, so the ball is thrown up. Okay, so the direction of ball adalah ke atas, upward. Okay, and then the force acting on this ball is caused by the gravitational force. We know that the gravitational force is always downward. Okay, so the angle between gravitational force dan juga displacement adalah 180 degree. So W is equal to Fs cos theta. F kat sini it will become mg darab dengan S cos theta. Okay, so ini adalah force disebabkan oleh gravitational force. So theta kat sini kita masukkan 180 degree. So it will become negative mgs. Okay. For the second case where the ball going downward. Alright. So the direction of displacement is downward. Okay. So the direction of gravitational force is always also downward. So the angle between force and displacement is 0. So cos 0. So the equation for work is W is equal to mgs. Okay, so look at the example 5.2. If we have a man lift a 20 kg bucket from a well and does 6 kilojoule of work, how deep is the well? So they ask the value of S. Okay, so we have the M is equal to 20 kg and the work done is 60 kilojoule. Okay, so the angle is 180 degree. So we know the value of work, we know the mass G, and we want to know the value of S. Okay, so we can calculate the value of S is equal to 30.61 meter. Okay, so exercise for 5.2. Okay, so saya nak tengok number 4. If a person does 50 joule of work in moving a 30 kg block over a 10 meter distance on horizontal surface, what is the minimum force required? Okay, so 50 joule adalah the value of work, and then this is the value of mass, and this is the value of S. Okay, so what is the angle between the force and the distance? So the force, if we push and move, so the force it becomes 0. So W is equal to Fs. So we know 50. We want to know the value of F, and we know the value of S is 10. So we calculate the value of force is equal to 5 Newton. Okay. Another example. Question number 5. A passenger at an airport pulls a rolling suitcase by its handle. If the force is 10 Newton and the handle makes an angle 25 degrees to the horizontal, what is the work done by the pulling force after the passenger walks 200 meter? Okay, so this is the handle of the suitcase, 10 Newton. Okay, so the angle between this one is 25 degree. And then S is adalah sebanyak 200 meter. So W sama dengan Fs cos theta 10 Newton darab dengan 200 cos 25. So awak akan dapat 1813 joule or 1.8 kilojoule. Alright. So you can try the other numbers, number 6 and number 7. So I will stop here first, and then we continue to another part. So see you on another part. Thank you.